Hello everyone, today we have to continue our solving trigonometry part 4. We are now in number 27. The question is find the co-function of tangent 12 degrees. So in this question, co-function of tangent, so tangent is a part of the trigonometric functions, and the co-functions of this tangent is cotangent. And we have the formula. We have 90 degrees minus the theta. Theta is the angle given. So our solution now is, we will write first the tangent 12 degrees, which is given, is equal to the co-functions is equals to cotangent. Then parenthesis 90 degrees minus the angle. This angle is equivalent to this given degrees. 12 degrees is an angle, and that's why we have now equals cotangent 90 degrees minus 12 degrees. So we have now cotangent 70 degrees. 70 degrees is the difference between 90 degrees minus 12 degrees. Okay, next number 28. Find the co-functions of cosecant 40 degrees. So remember, the co-functions of cosecant is secant, and our formula is 90 degrees minus the theta, which is the given angle. So our solution now, we will write cosecant 40 degrees is equals to the secant, and the formula 90 degrees minus the theta, which is the angle given, is equals to the secant. 90 minus 40 degrees. So we have now secant 50 degrees is our final answer. So the cosecant 40 degrees, the co-functions is secant 50 degrees. Okay, number 29. Find the co-functions of secant 50 degrees. So our solution, we have now copy first the givens. Secant 50 degrees is equals to our formula. The co-functions of secant is cosecant, and we have 90 degrees minus the theta. Theta is the angle given, 50 degrees. So that's why we have equals cosecant 90 minus 50. This 50 came from the given. This is our formula, the theta, which is the angle. So 90 minus 50, now we have cosecant 40 degrees. So the co-functions of secant 50 degrees is cosecant 40 degrees. Next is number 30. Find the co-functions of cotangent 64 degrees. Our solution, cotangent 64 degrees, copy first the given, and equals to the co-functions of cotangent is tangent, and the formula is 90 degrees minus the theta. The theta, this represents as the angle given, 64 degrees. So that's why we have equals tangent 90 minus 64 degrees, and the difference is tangent 26 degrees. So the co-functions of cotangent 64 now is equals to tangent 26 degrees. Okay, next number 31. Find the co-functions of cosecant 64 degrees, 24 minutes and 24 seconds. So our solution, just copy first the given. Cosecant equals to 64 degrees, 24 minutes and 24 seconds equals to the co-functions. The co-functions of cosecant is secant, and the formula is 90 degrees minus theta is equals to the secant. Since this is 90 degrees, it becomes now 89 degrees, 59 minutes and 60 seconds. Why? Because we borrow 1 degree from 90 degrees, it becomes 90 degrees, now becomes 89 degrees. And the borrow 1 becomes now 59 minutes rather, because we borrow again another 1 minute, and it becomes now 60 seconds. Then we have to minus now the given 64 degrees, 24 minutes and 24 seconds. So 60 minus 24, we have 36 degrees. 59 minus 24, we have 35 minutes. And 89 minus 64 equals 25 degrees. So this is now the co-functions of cosecant 64 degrees 24 minutes and 24 seconds is equals to the co-function of secant 25 degrees 35 minutes and 36 seconds. This is our final answer. Next, number 32. Find the hypotenuse of the triangle without using the Pythagorean theorem. So another approach that we're going to use, because the Pythagorean theorem, we're going to use the standard formula, which is c squared is equals to e squared plus b squared. This time, since the given is 1630 degrees is special triangle, acute 30 degrees angle, and also 60 degrees is acute angle. If we're going to add 1630 equals to right angle, and the given now is 5 degrees, the opposite of this, the side of this 30 degrees opposite is 5. This leg here of the triangle is 5 given. We don't have hypotenuse, and we're going to find the hypotenuse. How to do this? So our formula, our solution, hypotenuse is equals to the opposite of this 30 degrees, which is 5, and over 1/2, then we're going to multiply. Since this is fraction, we're going to reciprocal 5, it becomes over 1 times this 1/2 reciprocal becomes 2 over 1, then we're going to multiply. It becomes now 5 times 2 equals 10 divided by 1 equals 10 also. So this is now the hypotenuse of this given triangle. Okay, 1/2 is a constant. Okay, next, our next number is 33. Find the 6 trigonometric functions of 45 degrees. So without using the Pythagorean formula or theorem, we will use other way by using this special triangle. 45 and 45 degrees belongs to special triangle. And if we're going to add 45 degrees and 45 degrees, we have 90 degrees. This is the symbol of 90 degrees in the right triangle. If we have this, and for example, this is 1 here. So we're going to find the sine 45 degrees. So if this is sine here, the opposite of this is sine, the side. So sine 45 degrees is equals to 1 over square root of 2, the hypotenuse. And then since we have radical at denominator, so we are going to rationalize this, because we cannot answer in a radical form with a denominator in the form of radical. So that's why we are going to rationalize this. So to rationalize, we're going to think a number that if we're going to multiply this denominator become a perfect square root. Okay, now 1, it becomes the square root of 2 over square root of 3 is our estimated number to multiply in order to have the perfect square root. 1 times the square root of 2 is equals to square root of 2, and 2 times 2 is equals to square root of 4. Then we're going to subtract now the square root of 4. So we have now copied the numerator, square root of 2 over the square root of 4 is 2. So our final answer for sine 45 degrees is square root of 2 over 2. And for the cos 45 degrees, we have cos, we have the square root of 2, the hypotenuse, and over 2 here. Okay, now tangent 45 degrees is equals to, we have 1 and 1, tangent 1 and 1, so 1 over 1 equals to 1. And next is cosecant 45 degrees. So it's just the same with the result of sine 45 degrees. So the same answer we have. We have the same answer rather for the cos 45 degrees. But here the cosecant 45 degrees is the reverse of this number. So we're going to square root of 2 over 2 becomes now 2 square root of 2 times 2. We're going to rationalize. So it becomes now 2 square root of 2 over 2. Then we're going to cancel 2 over 2. So that's why the answer is the square root of 2. For the second 45 degrees is also square root of 2 because they are the same. Because secant is 45 degrees, secant 45, the result is the same. Also the same with 45 degrees, and sine 45 is also the same. And for the cotangent 45 degrees, 1 over 1 equals to 1 is also the same with the result of tangent. Okay, next, number 34, find the reference angle of 125 degrees. So we have to think first, since the question is reference angle, so remember you have to recall that and once rotation in a circle is equivalent to 100 is 360 degrees. Then, and the half of a circle is 180 degrees. Since the given is more than 90 degrees but less than 180 degrees, so our reference degrees now is 180 degrees. So 180 degrees now minus 125 degrees is equals to 55 degrees. This will be now our reference angle of 125 degrees. So again, so if it is more than 90 degrees, but less than 180 degrees, so our reference is 180 degrees. Reference angle. Okay, next, number 35. Find the reference angle of 250 degrees. Oh, this time, our reference angle is, the given is 250 degrees. Since 250 degrees is more than 180 degrees, so we will start now. Our basis of our computation is 250 degrees minus 180 degrees. It becomes now equals to 70 degrees. So our final answer for our reference angle to 250 degrees is 70 degrees. But this 250 degrees is not more than 270 degrees. Okay, next, number 36, find the reference angle of 285 degrees. So our solution here, since our reference angle given is 285 degrees, so our basis of our computation, since this 285 degrees is more than 270 degrees, so we will use the 360 degrees. Then minus the 285 degrees, so that's why we have the positive result of 75 degrees. So this is now our answer for this question.